Hello everyone. In this video, we'll look at measures of dispersion. Um, so what is dispersion? It's the degree to which numerical data tend to spread out about an average value. Um, so we will look at different measures of dispersion in this video, including the range, which is the difference between the largest and smallest numbers in a data set, and we'll compute it using um, using this equation. So x range is equal to x max minus x min. Um, then we'll look at semi-interquartile range, which is the difference between the third quartile and the first quartile divided by 2. So, like in the previous video, we have discussed that median is the value that divides the entire data set into two equal parts. So, a similar way, quartile divides the data sets into four equal parts. Um, and then we'll look at the 1090 percentile range, which is the difference between the 90th percentile and the 10th percentile. So percentile, like quartile and median, divides the data into 100 equal parts. We'll also look at mean absolute deviation using this formula, so which is the a sum of absolute difference of each value and the mean of the entire data set divided by the total number of values in the data set. Um, After that, we'll see how we can compute the standard deviation. So instead of taking the sum of absolute value of the difference between each value and the mean, we'll take the square of the difference of the each value um, and the mean of the entire data set, and then sum those values, divide it by the total number of values, and then take a square root of the outcome. We could also calculate the standard deviation using this formula here. Then the variance will be just the square of the standard deviation. So these are the absolute measures of dispersion. So there are also relative measures of dispersion that we sometimes use. So those are coefficient of range. So this is equal to the range value that we computed divided by the sum. So this should be sum of x max plus x min. Um, and then the coefficient of variation is just the standard deviation divided by the mean values. And the coefficient of mean deviation is mean absolute deviation divided by the mean value. And finally, we look at coefficient of quartile deviation, which is the differences of third quarter and the first quarter, which is interquartile range, and then the sum of third quarter, then divided by the sum of third quarter and the first quarter. So that will give us the coefficient of quartile deviation. So all of these coefficients are uh, computed as a percentage value. So we'll keep it just between 0 to 1, but that's 0.46 will mean actually 46%. Okay, so these are the deviation measures of deviation values that we will compute or see how we can compute this using Python. So let's look at an example. So like our previous video, we have this data set. So given x is equal to this list here, we will try to compute the above measures of dispersion. Uh, so for that, we'll be using Numpy in this video. So we are importing Numpy as NP. And then for plotting data set, we'll use matplotlib byplot. So we'll import matplotlib.byplot as plt. So let's run this cell here. Here we have the same data that was provided to us, and we'll save it as a Numpy array. Okay, and the first step is to compute the range. So as I mentioned previously, so it's just the difference between the maximum value in the data and the minimum value of the data. So x dot max minus x dot mean. So that will give us the range value, which is 4.1. So if we look at the data, so we have 6.5 as the highest number, and then 2.4 is the smallest number. So the difference between 6.45 minus 2.4 is 4.1. And then the third quartile, for quartile computation, we'll use the percentile functions and numpy.percentile. So we'll give the input array, and then we'll compute the 75th percentile, which is the Q3 or the third quartile. And for first quartile, we'll compute the 25th percentile. Then we'll take the differences between the third quartile and the first quartile. That will give us the interquartile range. And for semi-interquartile range, we'll divide the interquartile range by 2. So if we run this cell, so we'll have our semi-interquartile range for this data set is 0.449 or 0.45. Next, we'll compute the 1090 percentile range, which is P1090. So, which is the difference between the 90th percentile and the 10th percentile here. And the value here is 2.68. For the mean absolute deviation, we'll take the difference between each value in the data uh, uh, and the mean of the entire data set, and then we'll take the absolute overall and then compute the mean. So that will give us the mean absolute deviation of the data set, which is 0.81 in this case. Then for standard deviation, we'll use the std function of numpy, so numpy std of x, and that will give us the standard deviation, which is 1.06 in this case. So these were the absolute measures of deviation. So now let's look at some relative measures of dispersion. So coefficient of range, as I said, is the range divided by the sum of max plus min. Um, in this case, it's 0.46 here, which is 46%. Um, Coefficient of variation will compute the standard deviation of the data, then the mean of the data divided by the mean of the data, and that is 0.23. Similarly, coefficient of mean deviation will divide the mean deviation value by the mean in the data set, and the result is 0.176. For coefficient of quartile deviation, we have the difference between 75th percentile and 25th percentile. That's the interquartile range. And then the sum of 75th percentile and the 25th percentile. So we'll divide the interquartile range by the sum of 75th percentile and 25th percentile, and which will give us the value of 0.096 here. So what we could do next is to plot the histogram of the entire data just to see the distribution. Okay, so this is the histogram of the data. you could see that we have some values at the center of the data, then we have some scattered values away from the center as well. So if we plot the absolute measures of dispersion, we will see that our semi-interquartile range is smaller than the mean absolute deviation, than the standard deviation, and then we have two high values at P10 and 90, and the range value of the data. So semi-interquartile range focuses on the spread of the middle 50% of the data around the median values. A smaller value indicates here the central 50% of the data has a relatively narrow spread in this case, and then a lower MAD. So we have a lower MAD value, so and the standard deviation. So both of them show the variability in the data, but MAD is less influenced by the extreme values. Therefore, we are seeing smaller values for MAD here. Um, so and then the P1090, so it is wider than the semi-interquartile range and the standard deviation, so showing more variability in the data in the 80% of the data distribution. A large range value indicates more variability in the full data set compared to the narrow central ranges. So we could see that the central range, if we look at the center of the data, we see more concentration, but when we look at the entire data set, so the variability, the data has more variability overall. Uh, okay, so now let's look at the relative coefficients uh, of the data. So we have this quartile deviation, coefficient, mean deviation coefficient, and coefficient of variation, and then the coefficient of range. Um, so again, like quartile deviation is smaller than the mean deviation, which is smaller than the variation, and then we have a larger coefficient of range. Um, so this indicates the larger amount of variability relative to the range or the entire data set. However, the um, median deviation coefficients and the coefficient of variation shows moderate variability in the data set, and the coefficient of quartile deviation, because it's um, a smaller number, so we'll say that it shows relatively low variability in the middle 50% of the data set. Okay, so that's it about measures of dispersion, and that's what we wanted to discuss in this video. I hope you like this video, and see you all in the next video. Thank you.